Dear students, today we will discuss an important topic, work, power and energy. I am Balwinder Singh from Government Polytechnic College, Guru Tegh Bahadurgarh district Moga. The concept of work, power and energy is very important for an engineer and particularly for first year diploma courses, because in every branch of engineering they will have to the knowledge of this work, power and energy. So, first we will discuss about what is work. It may be made clear that work and applied physics and work and daily life, they have a different meaning, as we will make it clear in the further discussion. But first of all, we what is work? Work is said to be done if a force acting on a body moves it through some distance. Whenever a force acts on a body and the body moves through some distance, we say that the force is doing some work. So, work is said to be done if a force acting on a body moves it through some distance. Suppose we have a body, we apply some force, it moves up to this distance, then we say that this force is doing some work. Work is said to be done when force acting on a body moves it through some distance. Then work is measured as the product of force and distance. The distance through which the body moves. The formula for work becomes work is equal to force into distance. Sometimes the force may be acting at certain angle and the body moves along horizontal . These arrows show that force and displacement, they are vector quantities, and then we will have component of this force in this direction, which will be F cos theta. You will study in the chapter of scalars and vectors that a force or any vector can be resolved into two components, horizontal component and vertical component. And this is the horizontal component in the direction of motion of the body. Body is moving along this direction. So, we take this component F cos theta. Then work is taken as this force component F cos theta into S, the distance through which the body moves. Or if we take the symbol for work W, then this becomes F S cos theta. Or we can take W is equal to F dot S. this dot is called dot product. So work is equal to dot product of force and displacement. In general, dot product is written as A dot B is equal to AB cos theta. If we have two vectors A and B, angle between them is theta, then dot product is or scalar product is written as A dot B is equal to AB cos theta. So because we have Fs cos theta, where theta is the angle between force and displacement vector which is in the direction of motion of the body, then work is equal to Fs cos theta, or work is taken as dot product of the two vectors. Which two vectors? Force and displacement. So work is equal to dot product of force and displacement. And this shows, because dot product of two vectors is scalar, so work is scalar quantity. It is very important that work is scalar quantity. You must have studied about two type of quantities, scalar and vector, in your lower classes. Scalar are those quantities which have only magnitude and no direction. Vector are those which have both magnitude and direction. So you must know the concept of what is dot product, what are scalar and what are vector quantities, and what is the value of cos theta, what is the value of sin theta. This basic knowledge is required for understanding the concept of applied physics. Different terms are used. So work, we have studied about work. What is work? Work is equal to dot product of force and displacement vectors. Now if we come to the units of work, we have two systems. One is called SI, another is called CGS. In your first chapter, you must have studied the systems of units. There are four systems: CGS system, FPS system, MKS system, and last SI. These are the four systems of units which we use for measurement of different quantities. The first three systems are for length, mass and time, and fourth SI system is for 7 basic quantities. In SI, we will have the units from this formula: work is equal to F into S, force into distance. If force is 1 Newton, S is equal to 1 meter, then work is equal to 1 Newton into 1 meter, and this is called 1 Joule. when force is taken in Newton, distance in meter, then work is measured in Joule. On the other hand, if we have force 1 dyne, distance 1 centimeter, then work is equal to 1 dyne into 1 centimeter. This is called 1 erg. The unit of work in SI is Joule. The unit of work in CGS is erg. Work is said to be 1 Joule if a force of 1 Newton displaces a body through 1 meter distance. 1 Joule वर्क ਅਸੀਂ ਕਦੋਂ ਕਹਿੰਦੇ ਹਾਂ ਜਦੋਂ 1 ਨਿਊਟਨ ਫੋਰਸ ਬਾਡੀ ਨੂੰ 1 ਮੀਟਰ ਡਿਸਟੈਂਸ ਦੇ ਥਰੂ ਮੂਵ ਕਰ ਦਿੰਦੀ ਹੈ and similarly work is said to be 1 erg if a force of 1 dyne displaces a body through 1 centimeter. So depends upon what are the units of force and what are the units of distance, then we will have the units of work. So work has 2 units, Joule in SI and erg in CGS system. So when we take 1 Newton and 1 meter, we say work is said to be 1 Joule. If we take force as 1 dyne and distance as 1 centimeter, then work is called 1 erg. So it is very important to note that there are 2 units, one in SI system and other in CGS system. We can have a relation between Joule and erg. We have just studied 1 Joule is equal to 1 Newton into 1 meter. We know 1 Newton is equal to 10 the power 5 dyne, 1 meter 100 centimeter or 10 the power 2 centimeter. You must have the knowledge of this. 100 can be written as 10 the power 2, 1000 can be written as 10 the power 3. Similarly, we can write these as in the power of 10. So by putting the values, 1 Joule is equal to 10 the power 5 dyne into 10 the power 2 centimeter, 5 plus 2 7 dyne into centimeter, and dyne into centimeter is called erg. So this is equal to 10 the power 7 erg. 1 Joule is equal to 10 the power 7 erg. This is the important relation between Joule and erg. When we are to convert from Joule to erg or from erg to Joule, we take this relation. 1 Joule is equal to 10 the power 7 erg, and we must be clear that 1 Newton is equal to 10 raised to power 5 dyne and 1 meter is equal to 10 the power 2 centimeter. Now work has 3 types. It may be positive, it may be negative, it may be 0. Positive work, negative work, 0 work. We have work is equal to Fs cos theta. Now, depending upon force, depending upon distance, depending upon the angle theta, the type of the work will be calculated. If theta is equal to 0 degree, that is force and displacement are in the same direction, force is in this direction, distance is also in this direction. Suppose a horse is pulling a cart, the horse, the direction in which horse moves, that is the direction of also that of the cart. So, between force and displacement the angle will be 0 degree. Then work will be equal to Fs cos 0 and cos 0 कितना आंदा है 1. So, this is equal to Fs with plus sign. This is why it is called positive, because the angle between force and displacement is 0 degree. Force and distance, force and displacement are in the same direction. Displacement is nothing but the distance in a particular direction. Displacement and distance. Distance is scalar quantity, displacement is vector quantity. So, this is why we take it. When we take the direction, this we take it as a vector. The second case is when theta is equal to 180 degree. Force and displacement are in the opposite direction. In this case, force will be in this direction and displacement will be in that direction, so that angle is 180 degree. In this case, work will be Fs cos 180 degree. 180 cos is minus 1. So, this is equal to minus Fs. Work done by friction is negative. When a body moves in this direction, the friction force acts in the opposite direction. So, angle between them is 180 degree, and this is why this work will be negative. When theta is equal to 90 degree, that is force is along this direction, S is in this direction, or force in this direction, S in this direction, angle is 90 degree, then work is equal to Fs cos 90 degree, and cos 90 is 0. So, this becomes 0. So, work may be positive, work may be negative, work may be 0. That depend upon the angle between the two vectors. Which two vectors? Force and displacement. Another case when work will be 0, that is when S is 0, then work will be 0. वर्क 0 कदों हो सकता है? ਜਾਂ ਤਾਂ ਫੋਰਸ ਤੇ ਡਿਸਪਲੇਸਮੈਂਟ ਦੇ ਵਿੱਚ ਐਂਗਲ 90 ਡਿਗਰੀ ਹੋਵੇ, ਜਾਂ ਬਾਡੀ ਦੀ ਡਿਸਪਲੇਸਮੈਂਟ 0 ਹੋਵੇ, ਮੀਨਸ whatever may be the force acting on the body, there should be no displacement, then we say that work is equal to 0. So, in physics and in daily life, this work has different meaning. Sometimes a person sitting on the chair for say 10 hours or 12 hours, we say that he is doing work, but in applied physics he is doing 0 work, because he is sitting on the chair and there is no displacement, although there may be some force acting on the body, but the work is taken as 0. So, these are the 3 types of work. So, we have studied about work, what is the work, what are its various units, is it scalar or vector. So, work is a scalar quantity. Another term was that what are the types of work, and sometimes we calculate work from these two vectors, say F is equal to Fxi Fyj Fzk and S is equal to Sxi Syj Szk, then work is taken as Fxi Fyj Fzk dot Sxi Syj Szk, and this comes in the scalar product this is very important. Whenever we have to calculate the work in terms of components, whenever we have given the force and distance or displacement in terms of components, then we will have to calculate the work in terms of these components. And note that this is not just a point, this is called dot. This dot is called dot product or scalar product. You will become clear in the chapter of vectors that this is very important term. The second term, we come to the second term, that is called power. It is defined as rate of doing work. Power is the rate at which work is being done. Rate means power is equal to work over time. If we denote power by P, W work time T, this formula becomes power is equal to work over time. We have just studied work is equal to force dot displacement. Hence, this power can be written as force dot displacement over time or force dot displacement over time. Displacement of time is called velocity. So, this becomes power is equal to power is the dot product of force and velocity. Dot product of force and velocity. Work was dot product of force and displacement. If force and velocity are in the same direction, then very important formula for this power comes out to be P is equal to F into V. So, we have two formula to calculate power. One is basic formula, work over time. Another formula, that is force into velocity. Whenever we are given work and time, we calculate the power by using power is equal to work over time, power is equal to W over T, and whenever we are given force and velocity, we calculate this by taking the product of force and velocity. What are the units of power? The SI unit of power is watt, written by also W. If work is equal to 1 joule, time is 1 second, then power is equal to 1 joule over 1 second. This is called 1 watt. Whenever a body is doing work at the rate of 1 joule per second, we say that its power is equal to 1 watt. So depending upon how much work it is doing in how much time, by using the formula work over time, we can calculate the power in watt. Bigger units are kilowatt, kilo means 10 raised to power 3, means 1000. Megawatt, MW, M capital, 10 to the power 6 watt. These are the very important bigger units, kilowatt, megawatt, which are used in our practical life and also in your diploma courses. So you must have the knowledge about this kilowatt and megawatt. And one practical unit of this power, practical unit of power is horsepower. In short, HP, and you must have studied 1 HP is equal to 746 watt. 1 horsepower is equal to 746 watt. So these are the different units of power. One is watt, bigger units are kilowatt, megawatt, and the practical unit is horsepower. We sometimes say that power of an electric motor is 5 horsepower. Power of this generator is 5 horsepower. So this power of engines is taken in term of horsepower. Then the last term is energy. Energy is capacity of doing work. How much a body can do the work, that is the capacity of that is called energy. So hence work and energy are same, hence the units of energy are also joule in SI, same as that of work. Energy is of different types. Energy is mechanical, energy may be heat, energy may be light, energy may be sound, energy may be nuclear, energy may be solar, there are many types of energy which we come across in different fields, and we must have the knowledge of these types of energies, how many types of energy are there. But we will restrict ourselves to this mechanical energy, which is further of two types. One is called kinetic energy, another is called potential energy. This mechanical energy can be split into two type of energy, kinetic energy and potential energy. Otherwise